Hi, I'm Mike Gunn.
Justin Corres.
I'm Tanner Stewart.
I'm Brett Milbratz, and this is our project on NFL Predictive Statistics. Now, our summary of the project, the question we want to answer is, can we use past statistics to predict what team will win the Super Bowl? We're going to use this by using a regression analysis and other statistical measures such as descriptive statistics as well as visualizations of graphs to help predict who we think could win the Super Bowl. Our data we use is league and championship team points for, points against, and salary cap from the year 2011 to give us the aspects of what goes into a championship team. Our methods that we use in Excel develop a regression equation and other visual data analysis such as the graphs that we'll see later in this presentation. And to end it, we will use our findings to predict this year's Super Bowl winner based on the statistics we analyzed. Now, our question framing is across all sports, each team shares one common goal, and that is to win a championship. However, each sport is different and involves different decisions in strategy and gameplay. So by comparing and analyzing different statistical measures of championship pro football teams, we plan to seek a common trend among these champion football teams. And if there is a shared group of statistics that will help predict a championship in professional football.
So our analytics problem framing, this is the statistical data from championship teams from the last 20 years across professional football will provide us an accurate sample of what it takes to win a championship in the sport of football. By comparing these data from these teams, the 32 teams, we can identify a pattern that demonstrates the statistical trends among championship teams. We will analyze the data to gain insights to the following questions. What is the average winning percentage of championship teams? We kind of want to get a grasp of how often teams, NFL football teams win in the regular season. How does the championship team scoring average compared to league averages? So this, we're looking at the championship team's offense, points per game compared to the average, see how much higher it is each game. Third, how does the championship team's defensive points allowed average compared to league average? This one we want to see how the championship team's defense compares to the average league's defense, and how does the average championship team payroll differ from league averages? This we want to see. We look at the total salary cap and see where the championship team's salary cap falls. So here's our data we found from Pro Football Reference. Here's the every year from 1996 to 2017. Here's the winner of the Super Bowl. Here's their win percentage, each Super Bowl team. Here we got 2011 data from 2011 to 2017 data of the team total salary cap to the max salary cap of that year. The average is 141 million for the teams, and then the league max average is 145 million. Here we got points per game league average from that year. League average from 1996 to 2017 was 21.57. In the Super Bowl winning points per game, the team average was 26.01, so that's about 20.5% higher than the league average, our Super Bowl team. Here we got league points against per game average. Super Bowl team, or the league average against is about 21.57. And then the Super Bowl winner points against is about 17.26. So on average, Super Bowl winning teams are allowing about 20% less than the average.
So the first thing we did when we were taking our raw data was we wanted to build a regression equation. And the first data that we decided to use for our regression equation was the points for and points against. So when we were doing this, we compared Super Bowl team scores and team averages for points for and points against league averages for the same categories. So when we did this, we found that we had an R-square of 6.67, which means about 67% of like the data, which is winning a Super Bowl or not, can be explained by this. The way that we determined whether a team would win a Super Bowl or not was by creating a dummy variable, with 1 being they won the Super Bowl and 0 being they didn't win the Super Bowl. So then we came over here and we made residual plots too to kind of see and visualize how our data, this model fit our data. And you can see that most of our points are relatively evenly spread out, which kind of signifies that this is a good model to kind of explain most of what's going on for the data. And we feel that a lot of other data, the other 30% or so, could be explained by different factors such as injuries or weather conditions or stadium conditions. Really other stuff that's kind of hard to just pull like a statistical measure for. So we decided to add the salary cap data that we collected from 2011 on into a regression. And when we did this, we found that our R-square for this one was only about 0.62, so 62% of the data could be explained by this model. One reason that this could be less than when we had the points for and points against, rather than just the salary cap 2, is because we had a more limited number of data points. So there was kind of less information that we could pull in, less data, so it's less statistical significance for this data set. So when we progressed forward, we decided to only use the points for and points against linear regression model that we used. So the next chart that we have here is a visual data piece, and what it is the offensive plot. So here on the left is the 1 and the 0s on the right, signifying the Super Bowl or non-Super Bowl winning teams. So as you can see on the left, more recently too, Super Bowl winning teams have more higher powered offense. This kind of signifies a trend in the NFL that you can see offense is increasing linearly, and it's kind of increasing at a higher rate for teams that win the Super Bowl. So offense has become more important in the recent NFL. Then we did the same thing for defenses. As you can see in the past history, defenses was critical for teams winning a Super Bowl, and you can really kind of tell the difference between them and teams that did not win the Super Bowl. However, more current defenses are allowing more points per game, and they are sometimes a little bit higher than the league average too. So defense has become less important in the current NFL, but it's still an important statistic to know when you're trying to calculate who will win the Super Bowl or not. The last information we have here is the salary cap plot. A lot of this is really just kind of comparable data, like they both grow at the same rates. Part of that is because it doesn't make sense for a team to try to spend way under the league salary cap or to spend way over because they're going to end up paying more taxes and stuff. So it really just kind of makes sense that the salary cap data for Super Bowl winning teams will just grow with the league max cap. So just to kind of summarize the methodology that we use again, we did use simple linear regression in developing our models. We used descriptive statistics in finding the averages of our raw data set, and we used visualizations to help develop the plots and stuff that we used. And to create those visualizations, we use pivot tables, which kind of just made it easier to pair the data together and get values that we felt were usable. Some stuff that we covered in class that we didn't use in our presentation, we didn't use t-distributions or hypothesis testings. We didn't really feel that it added the value and helped us achieve what we were trying to achieve with this project. So just to kind of summarize the model that we came up with again, so we use a linear regression, and that'll help us predict this season's outcome. So our equation is about a long decimal. I don't want to exactly read that entire thing. So it's the intercept plus that factor times points per game plus a negative factor times points allowed per game, which makes sense because the more points allowed per game you have, the less chance you have of winning. So it makes sense that negatively impacts your statistics. Then again, our R-squared is 0.67, so about 67% of the data is accounted for by this model. And again, just to cover that again, other influencing factors that could help be a reason that the R-squared is lower could be like win percentage, injuries, the weather, home field advantage. And just to summarize again, this R-squared was higher than including the cap data. And then another point is that we didn't include our win percentage in this because the league average for win percentage would be 50%, assuming half the games are won and half the games are lost. So it's really hard to kind of factor in and get a good trend from league averages from that data. So we felt it wasn't valuable to include in our regression analysis.
All right, so for our prediction, we selected the top 8 teams from each division from week 13 of the 2018-2019 season. Based off these teams, we ran a regression. They gave us a prediction of the next Super Bowl champion. Our prediction shows that there's only really 4 teams in serious contention. The Chiefs, the Saints, the Rams, and Bears are all pretty close to 1 for the prediction model. However, the Saints do show that they're having a better season than previous Super Bowl winning teams, and their p-value is above 1, giving them the best chance to win the Super Bowl. If we were going to use this, I'd probably say to throw all your money on the Saints to win the Super Bowl this year. All right, and in conclusion, we took the data from the past 20 years of the NFL champions and league averages. We broke this data down to discover trends in championship teams and how they can compare to league averages. We used Excel to develop a linear regression and other visual data to help us figure out a prediction for this year's NFL team. And then we used this to predict that the Saints are going to win the Super Bowl this year. And that's our best bet for our team to win the Super Bowl.
Throw the money on the Saints.
Yeah, hammer the Saints.
Hammer the Saints.